You write an observer class. It implements one interface, has one method, execute. You never instantiate it, never call it, never pass it anywhere. And yet, the moment some completely unrelated part of Magento saves a customer address, your execute method runs, with an object handed to it that somehow already has the right data inside. Today we open the real source behind that events.xml, the event manager class that dispatches, the event object itself, and the invoker that actually calls your code and trace the whole path, from a plain string event name to your execute method running. Welcome back to Magento Development Deep Dive. Parts 3 and 4 covered dependency injection and plugins, 2 ways Magento lets your code hook into the framework. Part 5 covers a third, older mechanism, events and observers. We're reading the real event manager class, the event object, the observer interface, and the default invoker, all from the same pin tag we've used all series, 2.4.9, so every file and line you see is something you can open yourself. By the end of this part, 5 things should click. What an event element in events.xml actually attaches one or more observer elements, each naming a class, to a plain string event name, not a class or interface. What the manager class's dispatch method actually does, line by line, when that string event name fires. Why the event object exists at all. It wraps your dispatched data and carries the event's own name before any observer sees it. What the invoker checks disabled, shared, the observer's actual class before it ever calls execute. And why an observer that doesn't implement the right interface throws a hard exception in developer mode, but only logs a warning in production, which is a deliberate, and sometimes confusing, design choice. Strip away the code, and the event system is 5 stages. Declare, a module's events.xml file attaches one or more observer elements to a named event, giving each a name and an instance class. Dispatch, somewhere in the framework, code calls the manager's dispatch method with that same string name and an array of data. This is the entry point, the thing that actually fires the event. Wrap, for every observer registered against that name, manager builds a fresh event object holding the data, and an observer wrapper carrying that event. Invoke, manager hands each observer's configuration and that wrapper to the invoker, whose job is purely to decide whether and how to call it. And execute, assuming the observer passes every check, the invoker finally calls your execute method, with the wrapper as its only argument. A few things help before we dig in. Part 4, on plugins, is useful. Contrast here: events are a completely separate extension mechanism, string named rather than class targeted, and it helps to see how differently the two are wired. Either a real Magento 2.4.9 checkout, or the GitHub tag open in a browser tab. Comfort reading basic PHP interfaces in XML is enough. No prior experience with publish, subscribe, or event-driven frameworks required. We'll build the vocabulary from the real source. This is the real customer module events.xml file. Notice the shape. An event element's name attribute is just a plain string, not a class or an interface. Customer address save before, customer address save after, sales quote save after. Each one can hold multiple observer elements, each with its own unique name and an instance. The fully qualified observer class Magento will build and call. Nothing about the code that triggers customer address save before needed to know these observers exist. The coupling lives entirely in this XML file. This is the entire real manager interface 1 method. Dispatch takes an event name as a plain string, and an optional array of data. That's it. Every single event fired anywhere in Magento, a product save, a quote update, a customer login, goes through this exact same 1 method contract, which is part of why the event system stays so simple to hook into, even though it's used everywhere. This is the real dispatch method's body. First, the event name is lowercase. Event names are case insensitive by design. Then, for every observer configuration registered against that name, sourced from event configs get observers, manager builds a brand new event object wrapping your data, sets its name, wraps that inside an observer object merged with your original data, and hands the whole thing to the invoker. Notice a fresh event and observer get built on every single loop iteration. 1 dispatch call with 3 registered observers means 3 separate event objects, not 1 shared instance. The event class itself is almost boring, which is the point. It extends Magento's plain data object, so every key in the array you dispatched with becomes a gettable property. The constructor's only real job is to set up an empty observers collection, a separate, older-style registration mechanism largely unused by the events.xml path we're tracing today. Everything else about the data you dispatched is just inherited data object behavior get and set by array key. This is the real, complete observer interface 1 method, execute, taking a single observer argument. That argument is the wrapper manager built 2 steps ago, the one merging your dispatched data with the event object under the key event. Inside your observer, calling getEvent on that wrapper is how you get back to the data the original dispatch call sent. Everything an observer knows about what happened arrives through this one parameter. This is the real Invoker default dispatch method, called once per observer by manager's loop. First, a disabled check if an events.xml entry sets disabled to true, often used to turn off a parent module's observer. The method returns immediately, nothing else runs. Otherwise, shared controls the object's lifetime. Shared false builds a brand new instance every single dispatch through the observer factory's create method, while the default, shared true, reuses one cached instance through get. Only after that decision does it call the private method that actually invokes your code. This is the exact method that finally calls execute, and it's more defensive than you might expect. It checks, at runtime, whether the built object actually is an instance of ObserverInterface, and only then calls execute. If it isn't, say, a typo in the instance class, or a class that forgot to implement the interface, the behavior depends entirely on application mode. In developer mode, it throws a hard logic exception immediately, which is exactly the kind of loud failure you want while building a module. In production mode, it only logs a warning and quietly moves on, which means a broken observer registration can fail completely silently on a live site. A few things trip people up here. Event names get lowercased by manager before any lookup happens, so casing in your events.xml never matters, but a genuine typo in the event name string still silently registers an observer that never fires, since there's no compiler to catch a wrong string. Setting shared to false isn't a one-time thing. The observer factory's create method runs on every dispatch, which matters if your observer's constructor does anything expensive. A broken observer wrong instance class, missing interface only throws in developer mode. On a production site it just logs a warning and the rest of the request continues, which is a common reason an observer silently doesn't fire for months. And events.xml isn't limited to the global etc. directory. Placing it under etc/frontend or etc/admin scopes those observers to just that area. Let's pull events and observers back together. An event element in events.xml attaches one or more observer classes to a plain string event name, no class or interface targeting involved. Manager's dispatch method loops every observer registered for that name, building a fresh event and observer wrapper on each iteration. The event object wraps your dispatch data, while the observer wrapper merges that same data with the event itself under one key. Invoker default checks disabled and shared first, and only calls execute if the built object genuinely implements ObserverInterface. And that last check behaves differently by mode. Developer throws, production just logs, which is worth remembering the next time an observer seems to silently do nothing. That's how Magento actually dispatches events and calls your observers, straight from the pin 2.4.9 source with every file and line cited. Part 6 moves to service contracts, interfaces, data interfaces, and the repository pattern that ties them together. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in part 6.